Question number 6. A curve has equation y is equal to ln 3x squared minus 5 divided by 2x plus 1 for 3x squared is greater than 5. Find the equation of the normal to the curve at the point where x is equal to under root 2. First of all, we will differentiate this to find out the gradient, which is dy upon dx, and then we will find the equation of the normal. As we know, ln 3x squared minus 5 is divided by 2x plus 1. So we will consider numerator as u ln 3x squared minus 5 and v as 2x plus 1. We will use here quotient rule of differentiation. U dash is, when we'll differentiate ln 3x squared minus 5, we'll have 3x squared minus 5 in the denominator and the differential of this bracket in the numerator, which is 6x. V dash is 2. We'll apply the formula dy upon dx is equal to vu dash 2x plus 1 multiplied by 6x upon 3x squared minus 5 minus 2 uv dash, which is minus 2 ln 3x squared minus 5 divided by v squared, which is 2x plus 1 whole square. This is dy upon dx, which is the formula for gradient. We have to find out the gradient at x is equal to under root 2. So in place of x, we will be substituting under root 2 plus 1 into 6 under root 2 divided by, if we will substitute here, under root 2 whole square minus 5. So this 2 and this will be cancelled out. So 3 2s is 6 and 6 minus 5 is 1. So we will have 1 in the denominator minus 2 and then ln 1 divided by 2 under root 2 plus 1. When we will simplify it, we will get 2 under root 2 plus 1 into 6 under root 2 minus 2 ln 1 is 0. So we will not be writing here minus 0 upon 2 under root 2 plus 1 whole square. So now we will cancel out this 2 under root 2 plus 1 by 2 under root 2 plus 1 as it is squared. So we have here 6 under root 2 upon 2 under root 2 plus 1. This is the gradient of tangent. For gradient of normal, we have to do negative reciprocal of it. It means that minus 2 under root 2 plus 1 upon 6 under root 2. To form equation of normal, we must have gradient and coordinates. For coordinates, we have x is equal to under root 2. We need to take out y. For that, we need to substitute this under root 2 in the equation, which is given in the question. 3x squared, it means that 3 under root 2 whole square minus 5 upon 2 under root 2 plus 1, which is ln1 divided by 2 under root 2 plus 1. So which will be 0. So we have coordinates here under root 2, comma 0. Now we'll form the equation y minus 0 is equal to minus 2 under root 2 plus 1 upon 6 under root 2 into x minus under root 2. Y is equal to minus 2 under root 2 plus 1 upon 6 under root 2 x minus 2 under root 2 plus 1 upon 6. This under root 2 will be cancelled out with under root 2 when we multiply minus 2 under root 2 plus 1 upon 6 under root 2 by under root 2. So we have final answer as minus 0.451x plus 0.638. Part B. Find the approximate change in y as x increases from square root of 2 to square root of 2 plus h, where h is small. So we have here delta x, which is equal to under root 2 plus h minus under root 2, which is equal to h. We have dy upon dx, which we took out in previous part, that is 6 under root 2 upon 2 under root 2 plus 1. Which is equal to 2.22. So now we can use the formula for approximate change, which is delta y upon delta x is equal to dy upon dx. We have the value of delta x, which is h, and dy upon dx, which is 2.22. So delta y is equal to 2.22h. Question number 7. Solve the equation 5 tan x minus 3 cot x is equal to 2 sec x for x is greater than or equal to 0 degree and less than or equal to 360 degree. First of all, we will simplify this equation. In place of tan x, we can write sin x upon cos x. In place of cot x, we can write cos x upon sin x. In place of sec x, we can write 2 upon cos x. We have to write this equation in terms of sin and cos. So now we will take LCM. We'll make the denominator same. Cos x, sin x. 5 sin x is to be multiplied by sin x, so it will become sin square x. 3 cos x will be multiplied by cos x, so it will be 3 cos square x is equal to 2 upon cos x. Now we'll multiply cos x sin x with 2 upon cos x, so we will have 5 sin square x minus 3 cos square x is equal to 2 upon cos x multiplied by cos x into sin x. So we will be left with 2 sin x. And when we will take this 2 sin x on this side, it will be minus 2 sin x. Now we have equation in terms of sine and cos. So we have to replace either cos by 1 minus sine square x or sine square x by 1 minus cos square x. We have here 2 sin x, so it's better if we replace this cos square x by 1 minus sine square x. So it would be 5 sine square x minus 3 into 1 minus sine square x minus 2 sine x is equal to 0. We'll simplify it. 5 sine square x minus 3 plus 3 sine square x minus 2 sine x is equal to 0. So now we have 5 sine square x plus 3 sine square x as 8 sine square x minus 2 sine x minus 3 is equal to 0. We have now hidden quadratic equation. So we will be solving it by middle term breaking or using quadratic formula. So we can solve it by middle term breaking as the numbers are very small and we can easily solve it using middle term breaking. To solve it easily, we can consider a as sin x, and we can rewrite this equation as 8a squared minus 2a minus 3 is equal to 0. So we can have factors of 24 as 6 and 4, which will give the result as 2. So we can write here 8a squared minus 6a plus 4a minus 3 is equal to 0. We can take 2a as common, 4a minus 3 plus 1 is common, 4a minus 3 is equal to 0. 2a plus 1 and 4a minus 3 is equal to 0. So we have here 2a plus 1 is equal to 0 and a is equal to minus 1 upon 2. 4a minus 3 is equal to 0 and a is equal to 3 upon 4. As we consider a is equal to sin x, so we can replace a by sin x now. Sin x is equal to minus 1 upon 2 and sin x is equal to 3 upon 4. We will solve these two equations separately. Alpha is equal to sine inverse of 1 upon 2. So alpha is equal to 30 degree. As sin x is negative 1 upon 2, so we have to consider third and fourth quadrant. In third quadrant, the value of x is 180 plus 30, which is equal to 210 degree. In fourth quadrant, x is 360 minus 30 degree, which is equal to 330 degree. When we will solve this, alpha is equal to sine inverse of 3 upon 4. So alpha is equal to 48.6 rounded off to 1 decimal place. As sin x is positive here, so we have to consider first and second quadrant. In first quadrant, we have x is equal to 48.6 degree. In second quadrant, it is 180 minus 48.6, which is equal to 131.40. Question number 8. A curve has equation y is equal to 2x minus 1 into under root 4x plus 3. Part A, show that dy upon dx is equal to k 3x plus 1 divided by square root of 4x plus 3, where k is a constant. As we know, here 2x minus 1 is multiplying by under root 4x plus 1. So we can use here product rule of differentiation. According to that, we have to consider this as u and this as v. And this can be written as 4x plus 3 with power 1 upon 2. Now we will differentiate. Differential of this is 2. Differential of v is 1 upon 2, 4x plus 3 with power minus 1 upon 2 into differential of 4x plus 3, which is 4. So we can cancel out this and this. So we have v dash is equal to 2 upon under root 4x plus 3. For dy upon dx, we will multiply u by v dash. So it is 2x minus 1 into 2 upon under root 4x plus 3. Plus 2 under root 4x plus 3. U dash multiplied by v or vu dash. Now we'll multiply 2x minus 1 by 2, so it will become 4x minus 2 divided by under root 4x plus 3 plus 2 under root 4x plus 3. Now we will make the denominators same. So we will have here under root 4x plus 3. This will remain as it is, as it has already under root 4x plus 3 in the denominator. But this will be multiplied by under root 4x plus 3. So this will become 4x plus 3. Now we will simplify 4x minus 2 plus 8x plus 6 upon under root 4x plus 3. Which is further is equal to 4x plus 8x is 12x minus 2 plus 6 is plus 4 divided by under root 4x plus 3. As we have to write in this form, k into 3x plus 1 upon under root 4x plus 3. So we will take 4 as common from here and we will be left with 3x plus 1 upon under root 4x plus 3, which means k is equal to 4. Part B, hence write down the x-coordinate of the stationary point of the curve, for which we will take dy upon dx as 0. So 0 is equal to 4 into 3x plus 1 upon under root 4x plus 3. So when we will multiply this by 0, we will be left with 4 into 3x plus 1 is equal to 0. 0 divided by 4 will be 0. So simply we will have 3x plus 1 is equal to 0 and x is equal to minus 1 upon 3. So x is equal to minus 1 upon 3 is the value at stationary point. Part C, determine the nature of the stationary point. For this, we will consider one of the value of x, which is there at stationary point, that is minus 1 upon 3, and another value which is lesser than this, and another value which is greater than this. Why do we do this? Because we know if the stationary point is this, if we will have the curve like this, on this side, the gradient of the curve would be negative, and on this side, it would be positive. But if it is a maximum point, then if here is a stationary point, on this side of the curve, the gradient is positive, and on this side, the gradient is negative. So if at lesser value, the gradient is negative, and on this side, the gradient is positive, it means that it is a minimum curve. So let's find out the gradient at minus 1 upon 3, it is 0. So we will take out the gradient at this point. We can substitute minus 1 upon 2 into dy upon dx, and we can take this form of dy upon dx. So dy upon dx is equal to 12 into minus 1 upon 2 plus 4 upon under root 4 into minus 1 upon 2 plus 3, which will give the answer as minus 2. So here at minus 1 upon 2, it is negative. For the value 3 upon 4, we will substitute 12 into 3 upon 4 plus 4 divided by under root 4 into 3 upon 4 plus 3, which is equal to 4.9. So this is positive. Therefore, the stationary point is minimum. Question number 9, part A. The diagram shows the velocity time graph of a particle P. P travels 3260 meter in 100 seconds, reaching a final velocity of v meter per second. So here it is v meter per second, here it is 30 meter per second, and the total time is 100. The total distance traveled is 3260 meter. As the distance is given 3260, so we have to form the equation including v. Distance is equal to 3260 is equal to area under the curve. There are three shapes under this curve. One is this triangle, another one is this rectangle, and the third one is this triangle. For the area of this triangle, we have half into, we have this from here till here 20, and from here till here it is 30. So 1 upon 2 multiplied by 20 into 30 plus area of this rectangle. And for this is 80 and this is 30. So we have 30 multiplied by 80 plus this triangle, which is half into height into base. So this one we have to consider as base, which is 40, and height is this, which is v minus 30. So half into 40 into v minus 30. When we will simplify it, we will get 3260 is equal to, we can cancel out this, 300 plus 2400 plus 20v minus 600. So 3260 minus, when we will add these values, 2400 plus 300, it will be 2700, minus 600 will be 2100. So 3260 minus 2100 is equal to 20v 1160 divided by 20 is equal to v. So v is equal to 58. On the axis below, draw the acceleration time graph for p. So first of all, we will take out acceleration at 20. So here we have acceleration is equal to 30 divided by 20, which is 1.5. Then acceleration at this point is, we have here 100, 58, and here we have 60, 30. As we know, acceleration is the gradient of this line. So we can write acceleration is equal to y2 minus y1, which is 58 minus 30, divided by x2 minus x1, which is 100 minus 60, which is equal to 28 upon 40, which is equal to 0.7. Acceleration from 0 till 20 is 1.5. So we can draw from 0 till 20 a line at 1.5. From 20 to 60, acceleration is 0. So we can mark here from 20 till 60, we can mark here the acceleration as 0. Then from 60 till 100 second, it is 0.7. 0.7 is here. From 60 till 100, we have to draw a line at 0.7. It's to part B. Particle Q is traveling in a straight line. The acceleration a meter per second square of Q is given by a is equal to 6 cos 2t at time t second. When t is equal to 0, Q is at point O and is traveling with a velocity of 10 meter per second. Find the velocity of Q at time t. It means that we have to find the equation for velocity. Acceleration is given 6 cos t. We can find out velocity by integrating this acceleration. V is equal to integral of A dt with respect to time. So velocity is equal to A is 6 cos 2t dt. Then we will integrate this. We will get 6 sine 2t, and it is to be divided by 2 plus c. Now we will substitute the value of velocity v as 10 and t as 0. So 10 is equal to 6 sine 2 into 0 upon 2 plus 6 sine 0 upon 2 will be 0. So c is equal to 10. Velocity of q at time t is 3 sine 2t plus 10. We can cancel out this 2 and 6. Find the displacement of q from O at time t. When we integrate velocity, we get displacement. Displacement is equal to integral of velocity with respect to time. So S is equal to integral of 3 sine 2t plus 10 dt. When we integrate sine, we get minus cos. So we will have minus 3 cos 2t, and it is to be divided by differential of 2t, which is 2 plus 10t plus the constant d. As we have considered c constant in the previous part, so here we have to consider different variable. Displacement is 0 when time is 0. So this can be used to take out the value of d. 0 is equal to minus 3 upon 2 cos 2 into 0 plus 10 into 0 plus d. So cos 0 will be 1. So it is minus 3 upon 2 plus d. So d is equal to 3 upon 2. So we have final equation of displacement as S is equal to minus 3 upon 2 cos 2t plus 10t plus 3 upon 2. Question number 10. In this question, all lengths are in centimeters and all angles are in radians. The diagram shows the rectangle ADEF, where AF is equal to DE is equal to R. The points B and C lie on AD such that AB is equal to CD is equal to R. Thus, AB and CD, they both are equal to R. The curve BC is an arc of the circle with center O, radius R. This is sector of a circle. Arc BC has a length of 1.5 R. So this arc has length 1.5 R. Part A, show that the perimeter of the shaded region is 7.5 plus 2 sine 0.75 R. Perimeter of the shaded region. So perimeter means the outline, which includes this R, then this, which is also R, then this length, then this length, DE, and then this length, and this curve part. We have to take out the length of BC so that we can find out the length of this EF. We have 1.5 R, which is arc length, and the formula for arc length is S is equal to R theta. With the help of this, we can take out theta. It is 1.5 R is equal to R theta. So R and R would be cancelled out. So theta is equal to 1.5. So this whole is 1.5. Now we have to take out this length. As we know, this is an isosceles triangle because if this is R, this is also R. We can drop a perpendicular from here, which will divide this into two right angle triangles. Here is a right angle triangle. And now this angle would be half of 1.5, which means 0.75. So we can say that this angle is 0.75. From here till here, it is half of BC. We have to take out this. We have this R and we have this half BC. So we can apply here sine 0.75 is equal to opposite upon hypotenuse. So opposite is half BC, which we have to take out, and hypotenuse is radius. So R multiplied by sine 0.75 is equal to half BC, and BC is equal to 2R sine 0.75. We have got this BC, which is 2R sine 0.75. Now we can take out perimeter. Perimeter is equal to, we have this R, we have this R. Perimeter is equal to R plus R to R plus R to R. From here till here, it is R, and this also R, and this as 2R sine 0.75. So this is 2R plus 2R sine 0.75. Then this circular part, which is 1.5R. 2R plus 2R plus 2R, 6R plus 1.5R, it is 7.5R plus 2R sine 0.75. We can take R as common. So we will be left with 7.5 plus 2 sine 0.75, and R can be written outside over here. So we have got the perimeter. Part B, find the area of the shaded region. Give your answer in the form kr squared, where k is a constant, correct to 2 decimal places. Area of shaded region is area of rectangle minus area of this segment. For area of the segment, we have to find out area of sector, from which we have to subtract area of this triangle. So area of shaded region is equal to area of rectangle minus area of segment. Area of rectangle is radius multiplied by 2r plus 2r sine 0.75. So r multiplied by 2r plus 2r sine 0.75 minus area of segment. For area of segment, area of sector, which is half r squared theta. Theta is 1.5. 1 upon 2 r squared into 1.5 minus area of triangle. Area of triangle, we can use the formula 1 upon 2 AB sine C. So here we have AB as R, so we can take R square sine C, which is 1.5. So we can write here minus 1 upon 2 r squared sine 1.5. Now we will simplify it. 2r squared plus 2r squared sine 0.75 minus 1 upon 2 r squared into 1.5 plus 1 upon 2 r squared into sine 1.5. We can take r squared as common. So we will be left with 2 plus 2 sine 0.75 minus, when we will divide 1.5 by 2, it will be 0.75 plus sine 1.5 divided by 2. When we will solve this using calculator, we will get the answer as 3.11. The value of k is 3.1.